So page 7, page 8, you can use chat, you can use mic or screen annotation. Question related to block 1. Define acceleration. How we define an acceleration? Yeah.
Change in velocity over
Unit time, or you can annotate on the screen as well. You can type. You have to mention rate of change in velocity. That's good. The best answer, because rate of change in speed, speed is a scalar quantity, velocity is a vector, acceleration is also vector. So rate of change in velocity is a comprehensive answer. Sometimes they say define deceleration, so decrease in velocity, rate of decrease in velocity. Or rate of change in velocity, that's right. Change in velocity over a time, that's also correct. Increase in speed is right, but try to mention rate as well. The next question, we have to complete a graph. A car starts from rest. So from 0 to 15 seconds, the car has a constant acceleration of 28. So means every second it changes the speed to. Then from 15 seconds to 32 seconds, the car has a constant speed of 28. Accelerate to 20, sorry, not constant acceleration, it reaches 28. And then from 32, the car has a deceleration of 2 until it comes to rest. We have to complete the figure. So from 0 to 15, so 11, 12, 13, 14, 15. So from 0 to 15, the car reaches 28. This is 28. So we draw, because a constant speed time graph, it's a constant acceleration, so it must be a straight line. So we draw a straight line. Then from 15 to 32 seconds, so this is 31, 10 boxes are equals to 10, so each is representing 1. So this is 32. So 32 from 15 seconds to 32 seconds, it move at a constant speed of 28. Then it has a deceleration, so we don't know how long it decelerated. We have this deceleration is given, but we don't know, and it until it comes to rest, so the final speed is 0. But how much time it will take to reach 0, that we don't know. So we have to we have the formula v is equals to u plus at. The final speed is 0. What about the initial speed? 28. Because it is decelerating, so we'll not substitute 2, we'll substitute -2. So -2. If it was accelerating, positive, and t. Now we want to find t. So this 28 will move other side. It will be -28 is equals to -2. And it will be -28 divided by -2 is t. So this will give us 14 seconds. So means it will take 14 seconds to stop. So from 32, 14 seconds, 32 plus 14 makes 46. So 41, 2, 3, 4, 5, and 6. So this is 46. And it has a constant deceleration. So whenever there's a constant deceleration, so we have to draw a straight line. This shows it has a constant deceleration. If it was a non-uniform deceleration, then it will be a curve. Is it clear, this one? So first it was having a constant acceleration for 15 seconds. Then from 15 to 32, it has a constant speed or no acceleration. And from 32 to 46, it has a constant deceleration. For figure, for the time 15 to 32 seconds, the car was in a circular path. The direction of the motion of a resultant state, for this motion state, the direction of resultant force. When object move in a circular path, what is the direction of the force? Whenever that is always towards the center. Whenever any object move in a circular path, the force should always act towards the center. So force is acting towards the, or directed towards the center. So here the direction of a resultant force on the car, it is towards the center. What happened to velocity? It changes because whenever object move in a circular path, it is always accelerating, not because of change in magnitude, it's because of change in direction of the velocity. So the velocity of object move in a circular path always changes. Okay. This question is about the work, energy, and power. A force is used to move an object from Earth's surface to greater height. Explain why gravitational potential energy of object increases. Explanation. When we lift an object, so height increase, but what height increase? The height of the center of the mass increases. Like the object will have a center of mass or center of gravity. The center of the gravity has increase in height or changes the height. That's why the gravitational potential increases. So whenever you refer the increase in gravitational potential energy, we'll mention the height increase or the height of center of the mass or center of the gravity increases. Yeah, it moves away from the surface or the height increase because the potential energy is mgh. Figure 2.1 shows a train moving upward towards the top of the mountain. A train transport 80 passengers, each of weight 65, through a vertical height of 1600. Calculate the increase in gravitational potential energy. So, but yeah, whenever you're solving a question, 1 mark is for writing a formula. Potential energy is mgh. What about the mass? 65 times 80 because 80 each is 65 and there are 80 identical passenger we consider. The gravity what we'll take 9.8 and the height which is 1600, 1600. Whenever the answer is big, the best is write in scientific notation. Like if it is, we have point here, so 1, 2, 3, 4, 5, 6, 7. So I can say 8.15 into 10 power 7 and the unit will be joules. The engine of a train has a power of 1500 kilowatts. The time to reach the top of the mountain is in 30 minutes. Calculate the efficiency. What is the formula for efficiency? Efficiency is the useful power. Efficiency is a useful power output divided by total input multiplied by 100. You can calculate the efficiency in terms of energy. You can also calculate efficiency in terms of power as well. So what is the use? Like this train is carrying the passenger upward. What is the useful power energy? Gravitational potential. And how much the train has a, this is the input power of the train. So what we can do, we already have this. So this 30 minutes is there, means how many, the time should always be in second. So 30 minutes we have to convert into seconds. So 30 multiplied by 60. So it will be 1800 seconds. Now, how to get the useful output? Because we already calculated this answer. It was 8.15 into 10 to the power 7. This was the gravitational potential energy divided by the time. So we'll get the useful power. So divided by 1800. What's the answer? That will give us a useful output. 8.5 exponent 7 divided by 1800. How much is this? Your this answer. 4. So 4.5 exponent 4. What is the input? Because the engine of a train has a power. So the engines are developing a power and lifting. So input power is 1500 kilowatt. So it will be 1500 into 10 to the power 3 because it's kilo and multiplied by 100. What's the answer? This will give us the efficiency. As you can see here, 3.3%. So efficiency of this is 3%. So whenever you are lifting an object, the useful energy is gravitational, and then gravitational energy divided by time, so you'll get the useful power output. And the input power is because of the engines are moving the train, so the input power is of the engine. So the power output, the useful power output divided by total power input multiplied by 100, that will give us the efficiency of this. So it's only 3% efficient. So how much energy is wasted? 97% of the energy is wasted in the form of heat because of the friction of the parts as well as the friction of the track as well. Like as it is moving on the track, so there will be friction. Is it clear, this one?